Let's see. Share. So when you go into the course, that right here is media gallery. When you click on that, it has the videos from
I see it now.
okay.
Thank you.
You're welcome. Let's see, what do I need? Sorry, my other class went over it, so I forgot to open. The outlines I use in class are right here. And we were still on section 1. Oh, I have it open somewhere. There it is. We were on table 6. So table 6. It's right here. There's 3 tables in a row that are good ones so that you know conversions if you're unsure. Ounces is the smallest when we're working with US symbols. And then there's the pound. 1 pound is 16 ounces. And then there's a ton. 1 ton is about 2,000 pounds, which is about the size of a subcompact car. An ounce is about the weight of a AA battery. And 16 ounces is a bottle of pop. I like that they give you examples so you can visualize it. Same thing with 7. A gram is about the weight of a paper clip. A kilogram is about a hardback book. So your textbook, if you had it in hardbound, it would be about the weight of a kilogram. And a tone is 1,000 kilograms. Notice that it's about the size of a subcompact car. So in metric, they have what's called a tone, and in the US measurement, we have a ton. They are pretty close to each other. They both weigh about the size of a car. One's a little bit larger than the other, but they're about the same. These are a lot of the common ones that you should know. 1 centimeter is about 4/10 of an inch. A centimeter is about the width of your pinky. An inch is about the length of your thumbprint. Meter is close to a yard. Remember, a yard is, they might even have that here. No, they don't. A yard is 3 feet, a meter is 3.3. So it's a little bit larger. Those ones, some of these you should know, like 1 meter, 3.3 feet. That one you should know. I will make a list of the ones that you need to memorize. But other than that list, then those ones I would give the problems. Actually, on a test, you could have these tables because you will be allowed formula sheets. And I even put what page those are on in your book from the outline. So if we look at the first one, the mass of a full-grown elephant is 4 tons. Well, if you think about the rules that we had for measurements, 4 tons, it's between 0.01 and 1,000. So numerical wise, it's in there and it is a measurement, but tons, I know tons is a lot, but I can't actually visualize that. So we could express it in more human terms. We could think about pounds. Oops, I don't know why the square's here. So if we look at our measurements and we go back to where the ton was. One ton is approximately 2,000 pounds. Well, if we convert 4 tons then to pounds, it's going to be very large. So we could do subcompact cars. If 1 ton is 1 car, then 4 tons is 4 cars. One way of thinking of it. So 1 elephant is the size of 4 compact cars. Then we can kind of visualize how big that really is. Now, it doesn't have to be cars. We could go 4. I don't like, the book uses lowercase t for ton, but a lowercase t is a teaspoon, so I'm not sure why they do that. Okay, so an elephant is 4 tons. We know that 1 ton is 2,000 pounds. Now, when you're doing your conversions, in order for the units to cancel, one has to be on the top and the other one has to be on the bottom. So if we have ton here, then we need to put ton here for our 2,000 pounds. Notice if we convert this to pounds, our tons would cancel. 4 times 2,000, 8,000 pounds. Well, that just got even larger. I know it's a lot, but I don't know. So I need to do something else. Well, we said we could use some compact cars. What if we use people? What does the average American weigh?
Male or female?
I'm sorry, I couldn't hear you.
Male or female?
Up to you.
I'm gonna say male at 200, 180.
200. Okay. So the average will do males. We said 1 male, approximately 200 pounds. Now you could have done, if you Google Americans, the average American is 180 pounds. If you Google the average person in the world, it's less than that. I forget what it is now. I Googled it yesterday, but if we say the average male is about 200 pounds, that's fine. So when you're working these out, it's just an estimate that you're getting. And if it's a little off, it's not a problem. Just show me this so I know you were using this conversion, and then I know how you got your answer. Now we want pounds. This is up on top, so pounds here should be in the bottom. That way they cancel. 1 on top, 1 on the bottom. We know 200 pounds is 1 male. So now we have 8,000 divided by 200. When you're dividing, you can cancel zeros. I mean, not that you couldn't just plug it into your calculator, but 80 divided by 2.
40.
So 1 elephant is approximately 40 males at around 200 pounds each.
Yikes.
So you can kind of think of it a little easier. Any questions on that? Now, when you're asked to do something like this, I mean, it can be anything. You want to be something that you're more used to. Like people we know, if we went from elephants to panda bears, I still wouldn't be able to grasp the size. So maybe I'd need to go with something more familiar. The cars, I think that's a good one because we're all used to a subcompact car. 4 cars is an elephant. Any questions on that? But when I leave it wide open, then you can go with anything. It's just you want to try and get your values between 0.01 and 1,000. So this 8,000 pounds, it's not wrong, but it's too large. You want to try and keep it smaller. Any questions on that? Okay. Now some of them will be more precise, like the next one. Somehow I got a U and an I don't know, I switched my sentences, but you're pulled over on the freeway for driving at a speed 100 feet per second. If the speed limit is 65 miles per hour, was I speeding? So this should be an I.
No.
No? Well, I'm not sure because I haven't done the problem yet, but we could convert one or the other to the same unit. So we know we have 100 feet per second. Per means to divide. 65 could be 65 miles in 1 hour. So we could either go from this one to feet per second or feet per second to miles per hour so that we can compare them. Since I wrote this one first, I'm going to go with 100 feet because that's the speed I was going. And we'll see how fast we were going. So we need to convert feet to miles and seconds to hours. And you can do them in the same proportions. Let's do time first because everyone's comfortable with time, I think. We need to get to hours. If we're at seconds, we can go from seconds to minutes to hours. We know 60 seconds in a minute. Now you need to decide which one to put on top. Should I put the 60 seconds or the 1 minute on top? Anyone?
60 seconds.
Yeah, because I have seconds in the bottom, so I need seconds on top because I want to get rid of them. That way they will cancel. So then the 1 minute goes in the bottom. We need to get to hours, not minutes, so we have to do it again. We know there's 60 minutes in 1 hour, and we want minutes to cancel. So we need 1 on the bottom and 1 on the top. So my minutes cancel. Now I have the hours. Any questions on that part? We got to go from feet to miles. Do we know how many feet there are in a mile?
5,280.
There's 5,280 feet. And this is one you definitely want to be comfortable with. Not that you couldn't have it on a formula sheet when you go to take your test, but you do want to be comfortable with that one. And we can just continue this on because multiplication can happen in any order. This feet is on top, so this one needs to be on the bottom. 5,280 feet. And I can cancel that then. This one can cancel with this one. They do not have to be next to each other. Now I have hour and miles. So if I multiply across, 6 times 6 is 36 times 1, and then 1, 2, 4 zeros. But you can use your calculator. And then I'm the bottom 1 times 1 times 1 times 5280. And then I would plug those in your calculator. If you had to do this without a calculator, I would round this to 6,000, so then it divides easy.
68.18 repeating.
I'm sorry, I couldn't hear you.
68.18 repeating.
Yep. So if we divide these, we get 68.8181818. This line above just means it's repeating. Now, if you're going to round, use this. So we were going a little bit more than 68 miles per hour, which means we were speeding. Not much, but every mile counts. Any questions on that?
No.
So this is one that's a little more straightforward. You would have to go in order. Well, I don't mean order by this. You can't just pick anything off the top of your head. It was more precise. Any questions on that one? So we would end in a
Always the
set.
allowed calculators.
You can use a calculator. Just any basic calculator. I like this one because when you're writing equations out, it keeps the whole equation. Like 5 times 8 divided by 4. Oh, I didn't turn on. It keeps the equation for you, and then if you're getting a wrong answer, you can go back and see if it was what you typed or not. It also, I don't know how to use it, but it will put answers in fractions for you. And then in scientific notation, most calculators will give you an E. Someone programmed this one during a test, but I don't know how they did it. But if I take instead of giving me an E, it actually puts the 10 there for the scientific notation. Whereas most calculators give you an E. That E is 10 to the 14th. So it is a nice calculator if you just want a basic calculator. At the beginning in the fall, they were only $10 at like a Walmart, Target. They might be a little more now because a lot of students have already bought them. Try eBay maybe. But you just need a basic calculator. And you can use Desmos if you want, which is free and it's online. Okay, the third one. Write the height 5 feet 7 inches. In centimeters. Well, the first thing is 5 feet 7 inches needs to be all in the same units. So we know centimeters was one of our tables to inches. Here it is. 1 centimeter is 0.39 inches. So if we convert all of this to inches first, then we can go to centimeters. I'm going to leave the 7 out and convert first. So if we convert feet to inches, then we could add on the extra 7 inches. Then convert to centimeters. Any questions on that? It's easier to go to the smaller unit than it is to make the smaller unit into the bigger unit, because then you're going to have decimals. And we also know centimeters to inches because centimeters are small. So I would go from feet to inches and then all of the inches to centimeters. You will always be allowed a calculator. Okay, feet and inches. How many inches are in a foot?
12.
12. Will we put inches or feet on the top?
Okay.
Inches, because we want 1 foot to cancel. So 12 inches is 1 foot. I put the foot on the bottom so that they would cancel. You have to have 1 on top, 1 on the bottom. 5 times 12. So 5 feet is 60 inches plus the 7 inches because the person was 5 foot 7 inches. That means they were 67 inches tall. To find out how many centimeters they were, we can use this conversion. So by writing the proportions each time, you know if you should multiply or divide. Because looking at this, it would take me some thought to decide, do I multiply or do I divide by the 0.39? But if I set up the proportion, there's no thinking about it. I know this inches is in top, so this one has to be in the bottom. So I don't have to think about it. My inches cancel, and I know I need to divide these. Any questions on that? So 67 times 1 is 67, and then I divide by the decimal. $171.7948. If you want to keep going, 718. That would be I mean, of course, this is still rounding, but it would be approximately 172 centimeters. Any questions?
No.
Okay. Table 9 is a temperature scale conversions, and it's on page 14. Right here. I would not expect you to memorize these because I do not have them memorized. The normal body temperature is about 98 degrees Fahrenheit. Express this in Kelvin and Celsius. 98 degrees Fahrenheit. So we look at the formula. If we go to Kelvin first, now we have Fahrenheit, so we would be using the formula in this column. If we wanted to go to Kelvin and we had Celsius, then we would use this one. So we have Fahrenheit, we use this one. So Kelvin equals 5/9 F plus 255. And this is our right. So we have Fahrenheit, you're just plugging it right in here. So it's 5/9 times 98 plus 255. And go ahead and plug it in your calculator so we can make sure we have the same answers. Should be getting 309.4 repeating. So it's approximately 309 degrees Kelvin. Any questions on that? Now to go to Celsius, you could use this formula now because you have Kelvin, or you can use this one. So this one, when you plug in Fahrenheit, this one we would plug in Kelvin. So we could go C equals 309 minus 273.
$24. Ah, 36.
Now we could also use Fahrenheit. Let's see if it's the same. So if we use Kelvin, the 309 minus 273, we get 36 degrees Fahrenheit. If we use this one, then we'd be plugging our Fahrenheit in, which was 98. Do we get the same answer? Now the formulas could give you a little bit different, but they should be close. Yeah. 36.6 repeating. Now, if we would have left the 0.4 here, they would have been closer. This would have been 36.4 and this is 36.6, so it's a lot closer, but. Any questions on that?
If we have a table with multiple options we use, can we use anyone? Does it matter for grading?
It doesn't matter.
Okay, thank you.
Any questions on that? Now, pure numbers are numerical values with no unit. One example is percentages. So when we're comparing different things, if we can write them as percentages, then they're on the same scale. They don't have units. Percent is out of 100. And it can be written as a decimal, a fraction, or a percent. So if we had 0.25, that's 2 decimal places. So that's the same as 25 over 100. When you have a decimal, if you multiply it by 100, you get your percent. Is there any questions on converting from fractions to decimals to percents? So if we have 1/2. To make that a decimal, you just divide those. So if you plug in your calculator 1 divided by 2.5. To get the percent, you multiply your decimal by 100. So 0.5 times 100, 50%. So if you have a fraction, if you divide them, you get the decimal. If you multiply the decimal by 100, you get the percent. Any questions on that? Now, if we have the percent, to get the fraction, you just put it over 100. And reduce, the zeros will cancel and leave 3/10. To get the decimal, again, just divide. Any questions on converting? In 2015, the population of California was estimated to be 39 million people, while the population of the US was 320 million. So let's express California population as a percentage of the US. A percentage is a proportion. We divide the population of California by the total population. So if we want to compare a population, you always divide by your total. So California is part of the United States. The part goes on top. Now I could put all the zeros in a million, or remember, units can be canceled. Since they're both the same units, when we're dividing, we can cancel them. So then I don't have to put all of those zeros because they were the same unit. They were millions. There are also millions of people, if you wanted to put that there, and then the people also cancel. And that's why we're ending up with a value that does not have a unit on it. So 39 divided by 320. This would be our fraction. And it won't reduce. That is reduced. If we get the decimal, divide them. I'll put it over here. And to get the percent, multiply by 100. So looking at it fraction wise, this is a little harder to visualize. 39 3/20. The decimal shows you it's pretty small. And this shows you it's 12%. So California has approximately 12% of the population. Any questions on that?
No.
Let's look at number 2. Suppose that your electric bill is $70 each month. After following the advice contained in the EPA energy saving tips for renters, you managed to cut your electric bill by 15%. How much money are you saving each month? And then what will the new bill be? One way of thinking of it is 15% of 70, because we're saving 15%. Of means multiply. So if we're paying $70, 15% off of that, 15% of 70 would be multiplied by 15%. Now, when you multiply by a percentage, you have to write it as a decimal. 15% as a decimal divided by 100. So if you have the percent and you need a decimal, do the opposite, divide. Then you should get 0.15. You are also moving your decimal to the left too. So if you learned it that way, that works also. So to make a percent a decimal, divide by 100. Oh, I subtracted and said multiple. So we're gonna save 10.5 or $10.50 per month. To find out how much the new cost is, then if we take our savings and subtract them, we're now spending $59.50. So when you're finding a percent off or a percent increase, you can multiply by that decimal. And this is how much it will either increase or decrease. In this case, it was a decrease. So then we subtracted it. Now, if we didn't need the amount of the savings, if we just wanted how much the new price was gonna be, you can use what's called a 1 minus trick. And if it's an increase, then it's a 1 plus trick. What that means is you take your amount, and then because it's subtraction, 1 minus your 15%. This will give you the new price. It's omitting this step. So if you don't need the amount off, you only need what the new price is going to be, you can skip a step. So if we calculated this, we would get the same thing. The reason it works is because 15% off means you're paying 85% of it. 70 times 0.85 is 59.5. So if you're at the store and you're buying something that's 20% off, that means, because think of 100, if it's 20% off, you're paying 80% of it. So instead of finding 20% and then subtracting them, you could just find 80% and that's what you owe. Plus tax. Is there any questions on that? Number 3. A domestic electric outlet can deliver energy at a maximum rate of 3 kilowatts. That is 3,000 joules per second. A gasoline pump delivers gasoline at a rate of 1 gallon every 10 seconds. And each gallon of gasoline contains about 120 million joules of energy. See table 5 on page 488. Compare the rate of energy delivered by the electric outlet. I don't think we need to look at the page to do this one. I think I put all the information in here. 3 kilowatt hours is 3,000 joules. Compare the rates. Okay, so we could either take this one and convert it just like we did on another one when we compared things. You can start with one and go to the other, or vice versa. I'm gonna do Nathan. Oh no, we have joules here. So I don't know which one you want to start with, the 3 kilowatts or the 1 gallon.
The gallon.
The gallon. Okay, so if we start with 1 gallon per 10 seconds. We know that each gallon is about 120 million joules. So we can go from gallons to joules. 1 gallon. And we want gallons to cancel. Mhm. So I used right here. This proportion, 1 gallon of gas is about 120 million joules. And I put gallons on the bottom so they cancel. And we know it's 3,000 joules, so we can look at this to compare them. If we reduce, this is going to cancel 1 0. So this is 3,000 joules per second. And this is 12 million joules per second. But the thing you need to think about is the nozzle that it's coming out of also. It's a different size. If you think of your electric outlet and how small it is, and then you think of the gasoline pump and how large the hose is, that's why it's so different. The book even talks about if the gasoline pump was the size of a straw, kind of like your electrical cord, they'd be pretty close in the amount that they'd be reducing. To write it as a percent, we would just divide them. 3,000 and all the units, joules per second, will cancel. 3,000 divided by 12 million. Now, when plugging it into your calculator, notice these zeros will cancel with 3 of them. It makes it a little less zeros to have to type in. So it's just 3 divided by 12,000. And then multiply by 100 to make it a percent. So it's very different in the amount of size that they are. This is really small because this is a percent, not the decimal. Any questions on that? That's the last thing in that section. Any questions? Okay. We have a couple minutes. Is there any questions on the project?
No, we just have to reply to one other person's, right? Or was it 3?
I'm sorry, I couldn't hear you.
Sorry, I said we had to reply to one person's project or 3?
3.
3.
You
okay.
need to do an animal, a food, and then an item of your choice.
Oh no, when responding to someone else's project.
Oh, 3 different people. Mhm.
Okay. Yes. Thank you.
Sorry. I don't know why it's so hard to hear. I should have put my earbud in.
There is a tab that will give us all the criteria for the project, like what we need to have done and all that good stuff.
Yes.
All right, and I'm guessing it's on As You Learn somewhere. I can find it.
Here, wait, let me show you. Share. Under attendance homework project, it'll be here. This is an example. Then these 2 are just letting you know what you need to do. It just depends on if you want a Word document or not. And then this is the list of the attractions per person, which one you have. If you add it after this was made, let me know and I'll add it. So to do your discussion, you would click here, add new discussion, give it a title. And then if you did it to link it, you can click here. And then browse for it.
Okay. And I'm guessing those dates are still good.
Right.
Being 27th. Okay. Just double
And
check
then,
that.
yep, once you add it, you should not be able to see these until after you make your post, but then you would just click on someone's and do it. Some of them put what it was. Like you should know the Mile High Bridge. If you just came to app, then you want to go see the Mile High Bridge. I went over the summer. And so then here's the project, and then you can comment on it. So you want to comment on at least 3. I like it because then you can see other students' projects. It's taking some time to go up. Yeah. Very cool. And then it talks about it. So you would look it over, compare it. This is nice. I didn't get to see this one yet. Compare it to penguins. Hot dogs. So you want 3 different things. Oh, this is neat, a forklift. This is great job, whoever did this. But
Thank
does
you.
that answer your questions?
Yep. That
Great.
sounds good. Thank you.
You're welcome. And if you have any questions over the weekend, just send me a text or an email.
Sounds good. All right. Have a good one.
Have a nice weekend.
Have a good weekend.
Thank you.
Thank you. Have a good weekend.
You too.
I have a question.
Okay.
I was wondering do you recommend us like using a notebook to like record everything in? Because right now I'm just doing a bunch of like random sheets of paper.
What I would probably do if you are doing the random papers, I would get a little binder and keep them in it. That way, then when you're studying for the test, you have all of them together.
Okay. And can I also like do the assignment where like I meet you right now?
Wait, repeat that.
Can I do the assignment like where like we're supposed to meet you?
Yeah, you mean in like yeah.
Because I have to go somewhere in like a few minutes. So I just kind of want to get it over with, you know.
Sure.
All right, here we go.
So you mean office hours?
Yeah.
Okay.
Just because I have somewhere before 11.
Okay.
All right. Bye.
Bye. Anyone else did you have a question, Brooke?
I was gonna do the introduce assignment too.
Oh, okay, go ahead.
Do you want to go first, Nico?
Oh, is that what you meant, Nico? I'm sorry.
Yeah. I'm sorry.
I'm sorry. I thought you meant you wanted to go over the attendance homework. Okay,
Oh,
no, go
no.
ahead. Introduce yourself.
I'm Nico. I'm a psychology major. I forgot what was the other stuff.
That was about it. The main thing I wanted to make sure was that you were able to have your camera on. So when we
Right.
take a test, your camera's on. So that's all. You got your points.
All right, perfect. Thank you.
You're welcome.
Hey, I'm Brooke.
Hello, Brooke. How are you?
I'm good. How are you?
Good.
And then my fact or like something about me is I'm actually the first person in my family to get a cat.
Oh,
Dad hates him. Uncle hates him. Everybody.
but it's so cute. Oh my gosh. What's its name?
His name is Saturn.
Oh, that's a good one. I like that.
When I first got him when he was a baby, his eyes were like yellow on the center and then blue around the edge, and it reminded me of the planet. And then as he got older, his eyes turned like completely yellow.
Aw. But he's cute.
Yeah.
Did you have any questions on anything?
I'm
Okay.
good so far. Been taking my notes.
Good. Then I will see you Monday.
Monday.
Have a nice weekend.
Bye, guys.